When you're building software with AI, sometimes it feels like you can't actually trust your code, almost like you're building blind, right? Like you know when it works, but you don't actually know if it always works. And what if everything's great until you get to like 1,000 users and then the whole thing just falls apart right when you were taking off? Or what if in like 2 clicks, someone could hack your entire database, even though your basic security checks said you were fine? So I wish I could tell you not to worry so much, but the reality is I've seen every single one of these problems in real builds, including mine. I'm Isaac. I'm a full-time vibe coder at a multi-million-dollar company, and I've spent over 1,000 hours building production software with AI. So honestly, I hated worrying so much. So what I did was I got a senior developer to teach me how to actually audit my own software, and not just look through it, but really the way that developers do it in practice. And so that same day, I found hundreds of issues in my code. One of them could have cost me $30,000 in API credits literally overnight, one person exploiting it. If you don't know how to check for these problems on your own, you won't even find out they're there until it fails in front of someone who matters, like a customer, an investor, or even a hacker. I want to teach you what the developers taught me, so you don't ever have to worry about that happening to you. So by the end of this video, you're going to know the 5 most common things hiding under the surface of vibe coded software. And for each one, I'll show you exactly how to check yours right now so that you can trust that your build isn't going to come crashing down when you scale. Number 1, secrets living in your front-end code. So this is the most obvious one. And when I say secrets, I'm talking about things like your API keys, your database credentials, Stripe keys, that kind of thing. It's possible that they're sitting right in your front-end code right now, visible to anyone who knows how to look for them. It's because when you ask your AI to connect your app to Stripe or Supabase or really any third-party service, the fastest way to make it work is honestly to just like put the key right in the code. So sometimes that's exactly what it does. And it's not going to tell you that if a single person finds one of those keys, they could spend tens of thousands of dollars right out of your pocket, right? The AI just kind of does what works. But just to be clear, secrets should always live on the back end. Always live on the back end where users can't access them. I mean, that's why they're called secrets. And there's kind of a trap that is when we see an environment variable, sometimes we feel safe, like the .env, but that doesn't necessarily mean it's private, right? Like if it starts with next public or vite or expo public or some of these things, it's still in your front end. So those prefixes literally mean include this in the browser bundle. And so it ends up in the exact same place. Really, only server-side environment variables are actually hidden. And this is a big deal. So like GitGuardian found almost 29 million hard-coded secrets in public GitHub repos just in 2025. AI-generated code leaks secrets at twice the rate of human-written code, okay? So you've really got to be careful about this. And what the hackers are going to do is use automated bots that scan dozens or hundreds of online, web applications for exposed credentials, and they'll do this constantly. And when they find one, they can steal it and start using it pretty much instantly. So how do you check for this? There's a quick manual way to see it if you want. So what you can do is open your app in the browser, use F12, right, the dev tools, or you can right click anywhere and just click inspect, and then search for one of these terms on the screen. If you see actual credential values in your client-side JavaScript files, that means they're exposed. That means anyone who visits your app can do exactly what you did and find those secrets. But the more thorough way is to just ask your AI, right? Let's be real. And so you got to be specific though. Don't just ask, are there any security issues or like, how are my API keys, right? Say something like this: name every API key, secret, and credential in this project. For each one, tell me whether it's used on the client side or the server side, and whether it's hard-coded or loaded from an environment variable. So hard-coded means it's literally just written in the code. Nothing is putting it there. It's not pulling from anywhere. It's just there. Huge problem, right? And then to fix it, ask your agent to move every client-side secret to a server-side environment variable, and create back-end endpoints to proxy the API calls that are currently happening from the front end. Now, this is going to depend on the type of backend that you're using. So I use Supabase. Firebase is another big one, the Google side, that works really great. Generally, there's a spot in your database where you can keep these secrets secure, and they'll work with the front end, but they're not exposed, right? And so really ask your agent to help you if you need, and make sure it applies the solution to the actual tech stack that you're using, because it could be different. Number 2, your code base is a mess. Now, this one's sneaky because you really don't even notice it's happening. So every time you prompt the AI, it writes new code, but it doesn't remember what it already wrote for you like last week, last month, even the same day sometimes. And so it has these bad habits that it'll use, like it'll build a new version of something that already exists, and it does this all the time. Or, a new version, even a complete duplicate. Stuff like a function that does almost the exact same thing as another one, or even dozens of functions that have literally the same header duplicated for each one, right? They're doing the same thing and they have it written all over the place. Get Clear analyzed like 200 million lines of code, and they found that AI assistance led to an 8-fold increase in duplicated code blocks. 8 times. And here's why it matters to you specifically. You might say like, okay, well, it works. Why does it really matter? Why does it have to be perfectly organized? Well, there's a couple problems. And one of them is your database and really your app in general is going to be slower. Okay. Because if it's duplicated all over the place, that means that your code is doing the same processes multiple times, sometimes even simultaneously, which is super redundant. And it's also going to be more expensive because you need more processing power to get that to happen. So slower for the users, more expensive for you. And when you want to actually fix problems, if the code is repeated, that means the bugs are repeated too. So you can't just solve a bug once and hope that it will be solved everywhere. This is a big deal. And another reason, this is just the kind of thing that developers can't stand. It's really embarrassing when developers look at vibe coded software and find repeated code all over the place. It's one of the reasons they think that it doesn't work. Okay, so how do you check for this problem? First, ask your agent, scan this entire code base and find every instance of duplicated or near duplicated logic. Not just code, but logic. The difference is if it's doing the same task in different ways, then you need to consolidate and find the more efficient one and share it between them, okay? Then say, show me functions or code blocks that do the same thing in different files and group them so I can see how many copies exist. And you'll probably be surprised by how many it finds. To be honest, it's not your fault. It's something that the AI does, but it's going to pull up a whole list of duplicates grouped by category, by section. When I learned about this, I ran this check and I found hundreds of lines of duplicated code throughout my entire software. It was a big deal. Okay, and the fix is 2 parts. First, ask your agent to consolidate the duplicates into shared modules. It's called a shared helper. And essentially, it's a block of code that is written in one place, but sourced in lots of other places. What happens is every other file just imports from those instead of rewriting the same logic or just duplicating. You're definitely going to want to start in plan mode and do this in phases because it's a pretty big lift. Right? You're going to want to go specific into different parts of your software here. And second, going forward, have your agents always reuse existing code and patterns before creating anything new. This is actually a software best practice called dry. Don't repeat yourself. And what I do is I actually put this instruction into whether it's the Claude.md or the README, right? Like whatever file you have that instructs your agent for every chat on how to code in your tech stack. And really just that instruction alone makes a huge difference. Number 3, your app only works on the happy path. Now, what do I mean by that? The happy path is when everything goes right, the perfectly intended path. Okay, so that means the user fills out every field, the API responds instantly, the data is exactly what you expected. Great, right? But what happens when somebody enters like a 6,000 word response into the name input field? Or what happens when they like refresh the page right when it's loading a task? Or what happens when somebody submits the same form twice because they double clicked the button and it breaks the whole thing? Honestly, no matter how simple you make it, there's always like that one old guy who does exactly what you're not supposed to do. And that is where the AI built apps fall apart. Like, you know how it's supposed to work. And so you test it the right way, doing the things that a really reasonable person would do. But that just means your users who don't know those things are going to find the edge cases before you do. You don't just test the right way, you test every way, and there shouldn't be a single way to escape the flow that you're supposed to have. Okay. So research shows that error handling apps are about twice as common in AI generated code compared to human written code. Big surprise, right? The AI has a super strong happy path bias. What that means is like the user clicks a button, something goes wrong, and then they just get like a white screen or an infinite spinner, like a loading spinner. Problems like that are a big deal because they lose user trust almost instantly. They'll either get confused or worse, they'll just give up on the tool from the beginning. So here's how to check for that. First, when you're testing things on your own, try every common combination and scenario. That alone is going to surface a ton, and you have to do this. The easiest way to test your software is to do it yourself, okay? There's other more advanced ways that are great, but you have to test it. But I mean, for the less common scenarios, ask your agent for every API call, form submission, database query in this app. Tell me what happens when it fails. Does the user see an error message? Does the app crash? Does it hang on a loading spinner forever, right? List every case where there's no error handling or no user-facing fallback. That's a specific prompt, but sometimes you'll need to go even more specific into each section of your project because this is another big ask. If you just ask, like, does my app handle errors, you're usually not going to find the whole truth. What I'm talking about with error handling is like, if it's sending like a 2xx status error kind of thing, instead of telling them what actually goes wrong, it's going to really confuse the user. And then if there's no way to retry when it goes wrong in a reliable way, it's a big problem. Okay. So your AI is going to give you a couple suggestions or options, like it might fail in this case. And so you should go test a few of them and see if you can get your software to break. If you can, it's good news because you found a problem before the users did. So something like, submit a form with empty fields. I don't know, disconnect your Wi-Fi and try and use the app, and you'll see exactly what your AI is talking about here. And then for the fix, it's pretty straightforward, but have the agent add proper error handling. So show the user a super clear error message, prevent duplicate submissions, add fallback states when data is missing. It's probably going to be a lot bigger than just that one prompt, like I said, but this is going to get you started at least, and you'll know where to go from there. Number 4, your security looks right, but it isn't. So this is one of the scariest ones because it feels like you already handled it. Your app has authentication, it has login and sign up, even row level security, right? But the logic underneath might have holes that you wouldn't notice unless you knew exactly what to look for. So Wiz Research found that AI-built apps routinely ship with auth logic that can be bypassed. Admin-only endpoints that regular users can actually access, or RLS policies that exist but are super permissive. Auth checks that only live in the front end where anybody can modify them just by opening dev tools. Really, the idea of a false sense of security is huge when you're coding with AI. I've personally seen this in production where omitting a single field from a request bypassed all usage tracking and all subscription limits. They just took their organization ID out, and all of a sudden they're not charged to their organization, right? So your backend should always look up who's making the request from the authenticated session. Never let it trust what the front end tells it, okay? So how do you check this one? You ask your agent, but you got to be really specific. And this is important. Check every table in our database. For each one, tell me, is row level security enabled? What are the exact RLS policies? Can an unauthenticated user read or write to any table? Can a regular user access data that belongs to another user? Are there any auth checks happening only in the front end with no server-side enforcement? Those kinds of things. And you can go as granular as you want with this. Then ask this one too. List every backend function or API endpoint. And for each one, does it verify the user's identity before processing the request? Can any of them be called with just the public API key and no login? I asked that question and I found 13 exploitable endpoints in one of my own projects. You've got to do this stuff. Really big deal. Now, those specific questions force the AI to actually check the configuration instead of just giving you a high level, like, looks good. I mean, RLS is set up, and that kind of pattern is something that you'll use over and over. You don't just ask this once. You do teach it to build this way, but there will be also things that get through the cracks. And so this is important to continue. Number 5, you're deploying straight to production. Okay, this one is more of a workflow problem than a code problem, but it's when every change you make goes directly to the live version of your app, which is, obviously the version your actual users are on right now, or if you haven't launched yet, the one that they will hopefully be on soon. That means there's no staging environment where you can test first or automated testing that catches problems before they go live. There's no checklist you run through. It's just you, pushing changes and hoping that nothing breaks. Let me tell you, so everybody has a staging front end. Okay, if you're using Lovable or Bolt or Base 44, like those kinds of web-based tools, they're all going to have their preview there, which is great because you can make changes and you're the only one who sees it. Or if you're using Claude Code or Codex, Cursor, those kinds of things based on your computer, then you're going to run locally, right? Like localhost 5173 or 8080 or whatever you use. Fantastic. But what they don't have by default in these tools is a staging backend or a local backend. When you're making changes to the backend, whether it's migrations for updating the tables in your database or redeploying edge functions, you don't have a staging environment for those. That means any changes that you make on the backend instantly reflect for your live users. If you break something, if you delete data, it instantly breaks the app for every single user at the same time. Actually, this happened to me before I started running a staging environment for the backend. And what happened was, there was an entire university marketing class using my software to teach the class, and the software broke. It went down right during their class when they were all using it. It was the worst thing ever, right? They were emailing, trying to figure out, I got bad reviews. It was a disaster, okay? All because I didn't have a staging backend that I could break first to test that. I recommend you run your database locally with something like Docker Desktop. That works really well for Supabase, which is what I do. If you haven't set that up, really, every database change you make is live the second you hit save. And I can't tell you how nice it feels to be able to completely break both the front end and the back end locally so that I know it's not going to break live and I can fix it, get it ready, do all the tests I need, and then push. Super nice. In a survey of CTOs, 89% reported production disasters directly caused by AI-generated code. And when you're deploying blind like that, you find out about bugs the same way your users do. Something breaks on a Friday night and you go to bed, you don't even realize till Monday. Sometimes even worse, you don't even realize until somebody tells you, which is just, like I said, it's awful. And really that's what happens when you work directly in your live database. So this is one where the agent can't really diagnose the problem for you, but there's 3 questions that you can answer for yourself right now. First, do you have a staging or preview environment where you test changes before they go live, both for the front end and the back end? Second, Do you have any automated tests that run before deployment? I didn't talk a ton about this one, but this is a big deal. You can set it up so that it automatically tests in multiple ways, whether it's a linter, Dino testing, like Vite, all of those kinds of tests that can run every time you push an update. And third, do you have a checklist you run through before pushing every update? If the answer to all three is no, you're deploying blind. But your agent can help you fix it. Okay, so tell it, help me set up a staging database and a pre-deployment checklist for this project. I want to be able to test every change before it goes live. Okay, just to be clear, this is a big push. It's definitely not a one prompt fix. It's going to take a while. It might be frustrating, but it's totally worth getting it set up. Okay, so those are the 5, right? Expose secrets, duplicate code, no error handling, security that looks right but isn't, and deploying blind. So let me know, like I said, if you want to deep dive on any one of these, maybe all of them. I'm curious to see which ones are most important to you. I'd walk through not just how to fix them, yes, that, but also how to set it up so that your agents know to never make these mistakes in the first place, which is a lot more scalable. Make sure you subscribe to the channel if that sounds interesting to you. And if you want to work with me directly, there's a link in the description to book a free strategy session so we can talk through your project one-on-one. Sometimes it's just easier to go that route, right? So here's the deal. Software developers are going to see these statistics. They're going to see these horror stories. And they're going to say, that's what we told you. You have to be a developer to build software. You got to go to school for 4 years to learn how to do this stuff. I think they're wrong. I never learned how to code. I studied marketing, okay? But what you do have to learn is how to use the tools correctly. I'm talking about security best practices. I'm talking about code quality standards. I'm talking about scalability. All of those development best practices, super important. If you learn those, you can build an app that harnesses the speed of AI without losing the trust that comes with secure software. If that's interesting to you, stick around because that's exactly what I want to teach you. See you soon.